Welcome to lesson 2.5, multiplication of real numbers. So we've already looked at real numbers in general, where their positioning is on number lines, and then adding and subtracting real numbers. Now we are transitioning into the rules of multiplication of real numbers. So before we worry about the properties over here, I'm going to have you create this simple little two-part table with kind of a little simple cheat sheet about the rules of multiplying real numbers. So what we're always used to in the past was multiplying positive values. So for example, a positive multiplied by a positive will always give you a positive value. So 5 multiplied by 2 is a positive 10. So a positive times a positive will give us a positive. Then, if we're multiplying a negative and a positive, and remember, multiplication order doesn't matter, so this could be a positive first, then a negative, or a negative, then a positive. But if we have one of each, a positive and a negative, our answer will always be a negative. So again, a negative 5 multiplied by a positive 2 gives us a negative 10. And then we have a negative multiplied by another negative value. So a negative times a negative will always give you a positive. So a negative 5 multiplied by a negative 2 gives us a positive 10. So the way I like to remember it, anytime we're multiplying, same signs, always positive. Opposite signs, answers always negative. So then we have 4 properties of multiplication that we're going to look at and explore. The commutative property, again, just like the commutative property of addition, the commutative property of multiplication is the one that allows us to flip order. So A times B is the same as B times A, or a negative 3 times 5 is equal to a 5 times a negative 3. Either way, we get a negative 15. The associative property is the one that allows us to change the groupings within parentheses. So again, the way I remember associative property, if you are associated with someone, you're grouped with them. So the associative property is the one that allows us to change groupings. So if we have A multiplied by B in parentheses multiplied by C, that is the same thing or equal to A multiplied by, and then in parentheses, B times C. So an example of that would be the quantity 2 times 3 in parentheses multiplied by 4. And then that's equal to 2 multiplied by the quantity in parentheses 3 times 4. Either way, we end up with 24. And then our identity property is the one that says anything multiplied by 1 is itself. So A multiplied by 1 is equal to A. Or a negative 3 multiplied by 1 is still a negative 3. And then the final property that we're looking at is the inverse property. And the inverse property is that any number multiplied by 1 over itself, or its inverse, is equal to 1. So 1 over itself is known as the inverse. So any number multiplied by itself is equal to 1. So an example of that would be 2 multiplied by 1 over 2 equals 1. Or if we had like 73, 73 multiplied by 1 over 73 would equal 1. So example 1 asks us to find each product. Now remember, a product is the answer to a multiplication problem. So we are simply multiplying. So we can represent multiplication a few different ways in algebra. One would be with the dot in between. One would be a number next to a variable. Another would be with a number right outside of parentheses. So this representation is 9 multiplied by a negative 7. So a positive times a negative gives us a negative. 9 times 7 is 63. So a negative 63. In B, we have a negative 6 times a negative 12. Same signs. So two negatives give us a positive. 6 times 12 is 72. In C, we have negative 8 times negative 3 times negative 4. Negative 8 multiplied by negative 3 is a positive 24. Positive 24 multiplied by negative 4 is a negative 96. In D, we have 4 different numbers being multiplied. So a negative 2 multiplied by a negative 5 is a positive 10, bringing down what we didn't use. Positive 10 multiplied by a negative 6, as we work left to right, is a negative 60. Bring down the negative 2/3. Negative 60 multiplied by a negative 2/3 is a positive 40. And the shortcut again to multiplying a whole number times a fraction, a negative 60 divided by 3 is a negative 20, multiplied by a negative 2 is 40. In E, we have a negative 4 squared multiplied by a negative 3/8. So following the order of operations, we have to take care of our exponent first. So a negative 4 squared is a negative 4 multiplied by a negative 4. So negative 4 times negative 4 is a positive 16. Positive 16 multiplied by a negative 3/8. So we can think of that as 16 over 1 multiplied by a negative 3 over 8. The 16 and 8 can be simplified to 2 and 1. So we end up with a negative 6 over 1, or a negative 6. Then in example 2. Example 2, again, they're asking us to find each product. So the answer to the multiplication problem. Now, if we have variables, it is okay for our product or our answer to have variables in them. So in this case, if we have a negative 2 multiplied by a negative x, or the opposite of x, a negative 2 multiplied by the opposite of x would be a positive 2x, or 2 times x, but we'd read it as 2x because the negative and negative gives us a positive. In B, we have a 3 multiplied by a negative n times a negative n times a negative n. So in that case, we have a negative n to the third power, and then that's being multiplied by the 3. So 3 times a negative n to the third power. In C, we have a negative 1 being multiplied by a negative a squared. And the negative a is in parentheses. So the negative a to the second power gets done first. So a negative a times a negative a would actually be a positive a squared. And then a positive a squared multiplied by a negative 1 would end up giving us a final answer of a negative a squared. And then in D, y to the fourth gets done first when we have the negative on the outside. So y to the fourth would simply be y to the fourth, and then a negative times that would give us a negative y to the fourth without the parentheses anymore. And then our last two examples here, A and B in example 3, they ask us to evaluate the expression when x equals a negative 5. So evaluate the expression means to substitute in the negative 5 for x and then to solve. So if we're subbing in the negative 5, in part A, we have a negative 4 times the negative 1 times the opposite of x. So the opposite of a negative 5 would be a positive 5. So we would have a negative 4 times a negative 1 times a positive 5. Negative 4 times negative 1, positive 4. 4 times 5, positive 20. In B, we have a negative 9.7 multiplied by x multiplied by negative 2. So even before I substitute in the negative 5 for x, I can take the negative 2 times the negative 9.7, which gives me a positive 19.4. So I have a positive 19.4 times x, and x is negative 5. So 19.4 times negative 5 gives me a final answer of a negative 97. So the key to our multiplication of real numbers can kind of be summarized into this simple little chart and these 4 key properties.